Solve x cos y upon x plus y sin y upon x into y dx is equals to y sin y upon x minus x cos y upon x x dy. Answer. So the first thing we do is take dy upon dx on one side and put everything on another side. So we have dy by dx is equals to x cos y upon x plus y sin y upon x into y upon y sin y upon x minus x cos y upon x into x is equals to, now let's consider this as f of x comma y. By looking at the equation, we can directly say that it is a homogeneous equation, right? Because everything is symmetrical here. Now to solve, substitute y is equals to vx, differentiating it with both sides with respect to x. So dy by dx is equals to v plus x dv by dx. Substitute the value in equation. So v plus x dv by dx is equals to v cos v plus v square sin v upon v sin v minus cos v. Okay, so x dv by dx is equals to 2v cos v upon v sin v minus cos v. Okay, so we just put this v on the right hand side and then cross multiply it. Okay, so tan v minus 1 upon v dv is equals to 2 dx upon x. So we just reiterated the terms, that's it. So what did we do here is put this term on the left hand side, so it will get reciprocated, and then we gave this denominator 2v cos v to both the terms, that is sin v and cos v. So cos v got cancelled and got 1, and we will stay as it is, and then sin v upon cos v will become tan v. Okay, and v will get cut, and this 2 will be as it is here, so 2 dx upon x. Integrating on both the sides, we get log sec v upon v is equals to log c x square. So sec v upon v is equals to c x square. Substituting the values of v is equals to y upon x, we get sec y upon x is equals to c xy, xy cos y upon x is equals to k. This is the required solution.